meetups every month, mostly around the second week of every month. So you can check that out. And then we have Sydney CocoaHeads also. So I think they would be there having their meetup next month or probably next week. So you can check them out as well. And then we have the GDG meetup, which is quite similar to the CocoaHeads Melbourne, but this is for the Google developer group. So you can check them out as well. Move ahead. Okay, so we have a Slack channel. So any sort of discussions that you want to have, we have a dedicated Slack channel. So you can join us there at slack.melbournecocoaheads.com. So you can ask us questions during the live events at the meetup channel. So we will try to get back to you whenever we can. So as I said, we have a meetup channel. So you can chat with the organizers or even the speakers later on once they have completed the talks. There is another channel called volunteers. So as this is a community run event, we are always looking for new volunteers to help out. So you can join that channel and ask if you want to help. And there are always some sort of work that is needed. So check that out. And if you're looking for jobs or want to post for job listings, there is another channel called as jobs. You can post for your jobs and you can also look for new jobs over there. And at the end, we have a speakers channel. So if you want to give a talk or are planning to give a talk in the future, you can join the speakers channel and let us know. Let's move ahead. Okay, code of conduct. So Melbourne CocoaHeads takes the code of conduct very seriously. So this is a very short version of our code of conduct. So in a nutshell, what we want to say is that be respectful and be nice to each other. So there is a bigger version of this available at melbournecocoaheads.com and you can check that out. So at any given time, if you feel that you don't feel comfortable, then you can write us a mail at codeofconduct@melbournecocoaheads.com. So if you want to be anonymous, then you can also send us a mail via melbournecocoaheads.typeform. So all of these links are available on the CocoaHeads webpage. Let's move ahead. Stuff Victoria shipped. So if you have been working on any applications that you have shipped in this month or maybe the next month, you can let us know and we can put them in the slides and let everyone know. So this is also a great opportunity for you guys to showcase your application to everyone else. Let's go down. Okay, our gold sponsors. So I would like to thank ATBT Apps for being our gold sponsor. Moving on to our silver sponsors, I would like to thank Latitude Financial Services, REA Group, and we have a new sponsor on board, Cognizant, and we would like to thank both of our gold sponsors as well as our silver sponsors for helping out with this event and making this event come true. Let's move on to our first speaker of tonight. We have Matt Delves, who is going to talk about expression was too complex to solve in reasonable time. So Matt, if you're ready, the stage is all yours.
Across all three screens. I was hoping that I would get maybe the Slack or something onto my iPad, but it's like, no, it's like Keynote decided one screen for the actual presentation, one screen for the presenter slides, the usual two up displaying them, one for the presenter notes. So, my plans are foiled. Anyway, good morning. How is everyone? I hope you're all doing well. Typically this week is Dub week, but it's not. So what we're going to talk about is what happened at the last Dub, and that was SwiftUI. And we're going to talk about what happened, what's life been like since SwiftUI has come out, and what it's been like to work with SwiftUI for the past year. So, to begin with, hi everyone, I'm Matt. I am an iOS and macOS and watchOS and tvOS and whatever OS is going to come down the future developer. I love Apple products and I work with them because they're the best tech out there. If you want to find me, I'm Matt Delves everywhere on the internet, apart from Facebook, because I don't have Facebook and we don't talk about Facebook. My main project that I work on is Domestique, which is a cycling app. And like many others, I am currently looking for work. So let's get stuck into this whole idea of what is SwiftUI and what has been my experience of SwiftUI for the past year, working with it day in, day out. So let's talk a bit about the dream of declarative UI. So the idea behind a declarative UI is that you are writing an expression of what your UI should be, rather than writing about what the UI interactions are. So you are communicating to the thing that is running your app how the UI should be, rather than responding to any events that get sent. So Apple defines SwiftUI as it uses a declarative syntax so you can simply state what your user interface should do. Yay. For example, you can write that you want a list of items consisting of text fields, then describe alignment, font, and color for each field. Your code is simpler and easier to read than ever before, saving you time and maintenance. Let's unpack that. So, what is this dream or ideal of a declarative UI? The main things to think about, to work through and to consider is that it is defining your UI, that is how things look on screen, based upon the data that is available. So you've got this idea of a state that represents your app's view of the world. And with that, you are sort of saying different bits and pieces, and you're going, well, hey, let's present this knowledge and understanding of the world to the user through the app. So every time you update your state, you end up updating your UI. And that's something important to know and to understand, is that every time a value changes, every time something moves from one to the other, then you are going to get a new UI as a result. Now, SwiftUI has been out for a year. We've been using it in anger for a year, multiple projects, multiple ideas, multiple theories, and the community has adopted it fairly well. So how has this played out in the community? Well, everyone has an opinion, which is good and it's bad, in that when you go Googling for how should I do something, you get presented with a range of different ideas, range of different theories about what the best way to do something is. A lot of this is inspired from the web. And that is actually a good thing, because for the past 3, 4, 5 years, the web has been wrestling with and dealing with and trying to grapple with how does a declarative UI work? And they've come up with some really good answers that a lot of the community has adopted. A lot of this ends up being around, say, how do you make changes to the state? How do side effects happen and stuff like that? So things like Redux are usually some pretty good ideas around it all. You also have this idea of a composable architecture, and that's coming from the point3.co people. So that's what is it? It's a website that has produced a whole heap of functional programming oriented ideas, and they are presenting everything in that way, which is pretty cool in that they deal with a lot of stuff around how do you start to compose different parts of your architecture and stuff like that. So they've come up with this idea of a composable architecture, which has some benefits and has some drawbacks. And in order to use it, you really need to jump into and take hold of their way of dealing with things. And then you also have this whole idea of, well, why don't we just use plain old Swift objects? So let's forget all of this fancy architecture and just deal with structs and classes, value and reference types, and let's sort of use what SwiftUI and Combine are actually good at in order to drive the app, which is pretty cool. So we end up with all of this different back and forward around how best to architect an app. But apart from mentioning it now, we're not really talking about it in a great depth or great detail here. So how is SwiftUI being used? There are a couple of different approaches in that SwiftUI is being used in absolutely everything. And this is the approach I like to take, where it's just going full on into the world of SwiftUI. Every bit of the app is SwiftUI, and you're not trying to jump back and forth or hold multiple ideas in parallel as you go along. That's one way in which SwiftUI has been used. Another way in which it has been used is sort of more of a hybrid, in that for part A of the app, because it's existed for a while, it's still UIKit. Then part B of the app, because it's new, it's now SwiftUI and stuff like that, which kind of works. You're sort of jumping back and forth, making good use of both of the worlds, both of the ideas, and that's always pretty good. And then you sort of have this idea of, well, let's just use it in limited screens. So going, hey, this small, obscure part of the app will just test the waters here. And that's okay. All of these approaches are good because it's getting SwiftUI into the mindset and way of thinking of developers and people, and you're wrestling with the ideas of how can we adopt this technology. Now, as with any technology adaptation, there are a series of challenges that can come about. And having used SwiftUI in anger for the past year, there are some rough edges. There are some differences in opinion differences in ways of thinking that need to be addressed and understood and try to grapple with as you create an app. One of them is, how do you deal with large changes to data in a list? So if, for instance, you are trying to display a list of every city in the world and then make it searchable, how do you actually go about doing that? And that's one of the challenges that can come up, where you're wanting to do some filtering over this very, very large set of data and go from presenting everything to presenting maybe less than 1% of that data. It is a challenge. Another challenge is, how do you go about dealing with drawing of large canvas areas? So if you're dealing with, say, a shape, or you're dealing with a path, these, if you're not careful, can end up being pretty large. So what ends up happening is, if you're not careful, you will end up with a metal canvas that exceeds the maximum possible size. So one particular example is drawing a graph. And graphs are typically drawn based on the amount of data you've got there. And if you throw all of that into one shape, into a scroll view, then you may end up with a situation where metal will crash, because you're just saying, draw me this thing that is far too large. Another challenge that comes about is CoreData. Now, CoreData is great, it is awesome. Particularly in the last few years, it should be the default go-to if you want to persist large amounts of data. Unfortunately, with CoreData and SwiftUI, because of how SwiftUI wants to draw views, you will do this thing called faulting. And by faulting, you end up retrieving too much data from your store that has the effect of pretty much a very bad performance as a result. We'll touch on that in a couple of slides' time. Another one is image manipulation. So one of the things to realize with SwiftUI is that when you create a type, and then you apply a modifier to that type, you're not actually changing the initial type. You're instead getting a copy of the type with the change applied. So if you've got, say, a very large image, and then you apply 3, 4, or maybe even 5 modifiers to it, you are needing to process that image 5 times before it gets displayed to the user. And that can be it can have some very interesting performance results. Another one is this whole idea of what's my size? There was an entire talk at DubDub in 2019 where one of the presenters went on and on about layout guides and stuff like that to show how something gets laid out in SwiftUI. And still, it is a very hard problem to grapple with and to address. The other one is this idea of something is close, but it is not quite as you would expect. So in this case, you end up having a thing where you can create, say, 90% of a UI very, very quickly, and much quicker than UI can. But the finer adjustments, making it refined and behave like you really want, is going to take a while. Then there's this idea of a geometry reader. Now, everyone loves to go to geometry reader as a solution because they think, oh, now I can deal with frames and bounds and all of that stuff I know. You should never go for it as a solution. There are only two areas where I know it can be used and should be used. One is when you're drawing a shape. So when you're drawing a shape and drawing a path, you want to know what your actual dimensions will be, and Geometry Reader will give you that. The other one is Geometry Reader, apart from the size attribute, will give you your safe area insets. So if, for instance, you want to lay something out that sits a particular number of pixels or points above the touch bar or something like that, or the home bar, then the Geometry Reader will give you that option. So those are really the only two areas where you will want to use Geometry Reader. Okay, let's now circle back a bit to our list of challenges and start addressing them as we go through. So if you're wanting to, say, filter a list of maybe 200,000, 300,000, 400,000 items down to a list of maybe less than 100, how are you going to do this? And I use the example of a list of every city in the world before, and that's one example. But with my app Domestique, I've also grappled with this again because cyclists love recording their data and will have, say, maybe 10 years of data. And if they go out cycling every day, maybe once or twice a day because of commuting over those 10 years, that's a lot of data. So how do you then go from this very, very large set of data down to a very, very small set of data? And for this, you need to use CoreData. If you were to place everything into memory and use, say, cast everything as a single array, or get a view model that's a representation of all of your different bits of information in the app, then you are saying, hey, grab these 200,000 items and throw them into memory, and then do a filter over them, or a map, or even a multitude of all of these things. And that can be very, 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 very slow. And you don't want that. So what you want to do is you want to make use of things like CoreData. And particularly you want to make use of NS predicate, where you are creating and defining a very precise understanding of what is going on. And you can do filtering based on multiple conditions, and it works really, really well. So with this, what you want to do is, as soon as you start entering into that sort of search mode and that text, you want to actually discard all of your 200,000 items from being displayed and only display the results. So right at the start, you go, okay, as soon as they've entered that field, we will display nothing. So what I'm getting at here is this requires a lot of UI understanding and adjustment as you go on. And you want to make sure that you use CoreData in its predicate rather than filter and map on objects and values that sit in memory. The large canvas problem is one I came across when dealing with graphs and displaying sort of large amounts of data in a graphical way. You can very easily get to a point where your app will crash because it's trying to create a metal canvas that is too large. So what you want to do here is just break it up into smaller and smaller and smaller pieces. It gives you really good performance, and it means you don't end up having to deal with this one very, very large, very badly performing piece of view that sits on the screen. Now, as much as I say working with CoreData is amazing and I love it, there are a few things you need to think about when working with CoreData. Your model is important. So the actual way in which you think about structure and reference your data makes a really, really, really big impact on the performance of the app. If you're doing something like putting transformable values into CoreData, so you're, say, taking a JSON object and throwing it into a data field, and in order to retrieve or store that, you're going through a value transformer and stuff like that, then all of that requires processing effort, all of that requires memory, and as you are dealing with all of that and dealing with SwiftUI, you will end up realizing that SwiftUI will, for each item in a list, it will fault that data, which means it will go ahead and create the JSON decoder, it will retrieve it from data, it will parse it and represent it, even though you're not displaying it on screen. And this is what I mean by everything gets faulted, in that every bit of information, when you put it into a list, gets faulted, it gets parsed, it gets extracted from the database, and this can be really, really, really slow. So you need to know when your views are created, and you need to know what information is being accessed when. And this will allow you to have a good understanding of why a particular user interaction is potentially going to be very, very slow. Another problem I've come about is, again, based on how views get created and views get updated in SwiftUI. So if you are dealing with an API that returns images that are the equivalent of, say, a 4K desktop background, this is an exaggeration, but something of that scale, and you've got, say, 1,000 in a list, when displaying them, you typically want to do something like get the data for the image, then resize the image, set the scale factor like size to fit or size to fill or something like that, and maybe one or two other view modifiers on it in order to present it in a list. And what's actually happening is you're loading the image, and then you're loading the image as resized, and then you're loading the image as resized and sized to fit. So you're actually doing about 5 to 10 times the amount of loading of the image in order to present it on the screen. So you really, really need to make sure that what you're dealing with doesn't have to go through so many transforms with regard to images. That leads me on to my next point. Did I mention when views are created? So views, when they get created, it's not always when they will appear as we're used to in UIKit or AppKit. They get created when the code actually gets run. So in a list, say your list has 100 items, and all of those 100 items have a navigation link to something else. You will end up with potentially 100 extra views being created as a result of that list. Now, list being table view means that everything gets created a bit more nicely, but yeah. So make sure you know and you understand when views are created. Next thing to remember is that SwiftUI is slow. And this goes against everything everyone ever says about SwiftUI, mainly because it is very fast to prototype something, it is very fast to get something on screen. But when you end up dealing with a lot of data, SwiftUI can become very, very, very slow. So you need to be creative, you need to think about and understand what's going on here. Cool. Okay, that's all of the problems, all of the stuff I've had to deal with over this past year. Let's start to think about, okay, we are less than 2 weeks out from WWDC. Let's see, what do I think, what do I want out of SwiftUI going forward in 2020? What I want is something that's a bit more expressive, as in the code I can use stuff like guard-let, if-let, switch, and all of that. I want more UI components, like having a collection view or a grid layout or something like that would be amazing. Another thing I really want is better interactions with Apple's frameworks. So being able to get a map without having to do a UI view controller representable or the equivalent in AppKit would be amazing. Any of this add to Siri functionality, again, would be amazing without having to wrap all of that in a UI view controller representable. And that's all for my rant this evening. Thank you very much. I'm definitely looking forward to what is coming in the next couple of weeks. It should be amazing. It should be a lot of fun. And yeah, hope to see what everyone creates. Thank you.
Okay, thank you, Matt, for your amazing talk. Okay, so just a quick shout out. So the guys, if you want to interact with Matt, you can follow him on @MattDells on Twitter, or else you can jump on the Meetup channel on Slack and you can ask him any questions. Okay, let's move to our next speaker. So up next we have Mike, and he will be talking about building the enterprise.
Okay. Hi, everybody. I'm Mike Monahan. I'm here to talk to you today about building the enterprise. It's not exactly iOS and macOS, but I think it's kind of generally interesting for those in the sort of nerd universe. Yeah. So what I'd like to go through today is how we built an enterprise, a bit of background where it came from, the design, the electronics, a little bit of a demo, and how the software was written as well. Just to set the scene, this isn't a real enterprise. This is just a model of an enterprise. Okay. So the model that we're going to look at is the NCC 1701A, and I think most Star Trek fans would know that's from episode 4, Journey Home, out of the movies. So it's not the original series one, but it's pretty close in between, and it's not like the newest ones. So somewhere in between. And the story of this one goes back to my brother-in-law, Gordon. And Gordon was a very, very big Star Trek fan. I'm a moderate Star Trek fan. He was a very, very big Star Trek fan. And unfortunately, he lost his battle with cancer in 2016. But one of the things that Gordon did have was a model. And he had a Star Trek model that he'd intended to build, and unfortunately wasn't able to finish it. So I basically picked it up and I thought, oh, well, I'm going to build this and I'm going to do it as well as I possibly can. So anyway, it was a lot more complicated and it took a lot more time. But thanks to COVID-19, I had a lot of spare time on my hands. So there's a picture of Gordon there. You can see him with the crew of Deep Space Nine. That's when he was going through his Vulcan phase. I think we've all been through a bit of an awkward Vulcan phase. You know, our ears are too big, that sort of thing. But anyway, he was a very big fan. So anyway, that's a bit of background where the model came from. And so I picked it up. It hadn't been started yet. So this is how we went through assembling it and putting it together. So first I'll go through the design. So the design is fairly basic. You have the model itself, which is one of those plastic models. You glue it together with glue. You paint it. But to make it really come to life, it's all about the lights and the sounds. Yeah. So to do that, on the enterprise model, there's lots of parts that you need to get going. So we've got lots of lighting for the cabin, spotlights, there's navigation lights that go blinking, strobe lights, warp engines, there's crystals and dishes that need to be lit up, photon torpedoes, thrusters, we need the sound effects, and we need some push buttons to help change the modes. Yeah. Anyway, so the design is basically an Arduino processor and then lots of LEDs and a couple of switches to get the effects. So the ingredients, one model kit. I think I looked it up on eBay. You could probably find that for about $100. Probably add about $400 to it after you go through all the parts and glue and everything else. An Arduino processor. LED strips. I used about 4 meters of those. You can get that for about $8 or something around there. Lots of LEDs, a couple of special RGB LEDs that can do all different shades of colors. Lots of hookup wire, and I'll tell you why that's important. Resistors and transistors, a plug pack to give it power, a soundboard, speaker, a prototype board, and some switches as well. So first, I'll step you through maybe the electronics. Yeah, I assume you know how to kind of put plastic models together, but we've got some photos later on. So the first thing is the Arduinos, and that's really the brain of the outfit. Here's a picture of the Arduino, and what it is it's a reasonable processor. It can go through and do processing, but what it's called a microcontroller rather than a microprocessor. And a microcontroller is different because it's got lots of pins for input and output. And those input and outputs let you control lights, control motors, also receive input from sensors, temperature, geolocation, all those sorts of things. So controllers have lots of pins. This picture here shows all the pins on a Nano, which is a really small version of a computer. So you have some pins which you can use for input or output. Some pins have special functions called pulse width modulation, or PWM, and they're able to make a different sort of a wave signal. It lets you control how much power comes out of the pin. There's analog pins for inputs and outputs, and all these pins have a different purpose, and so when you're wiring these up, you've kind of got to think about what the purpose is for each different pin. Okay, so in basics, all you have to do is get some lights and hook it up to Arduino, and it's all good. So here we go. We get our 12-volt power supply, plug it into our Arduino, hook up an LED, and then we watch the lights go out. Unfortunately, it's a little bit more complicated than that, and hopefully I'm going to step through the bits that you need to look at. Okay, so there's 3 problems that we need to solve. The first problem is an Arduino can't supply enough power for LED strips. So those LED light strips, they use a fair bit of power, and an Arduino can't do it. So we need to find a way to give enough power to those strips. The next thing is that LEDs can't have too much power or else they pop. So if you put too much power through an LED, it'll grow bright for a second, and then it'll go off and it won't work again. So you need to control the amount of power to them. And the last item is that LED strips need 12 volts and Arduinos use 5 volts. So there has to be a way to change the amount of voltage that you're going to give to your Arduino processor. So first problem is, how do we provide enough power to LED strips? Since the Arduino can't give us enough power and the LED strips need it, then we need to find a solution. And really the solution is to use a transistor. And a transistor in this picture here, I've got, lets you control a larger voltage. So what we can do is we can put 12 volts in at the bottom, and using that little transistor sitting there next to Arduino, it's able to act as a switch, and it lets you turn on and off 12 volts, whereas the Arduino sitting in there using only 5 volts. So that kind of lets you just use one little pin and to control that switch to turn on and off the light. Okay, the next problem is not blowing out our LEDs. For that, the trick is to use resistors. So if we have something like 12 volts in that diagram there, then you need to find a way to make sure that each of those LEDs only use up as much energy as they need and not too much. So in this particular equation, different LEDs use a different amount of voltage. Those little blue ones use about 3.3 volts and a certain amount of power. Now, if you kind of add it up easily, you need to say, if you added up those 3 LEDs, and it'd have to add up to 12 volts, you can sort of, this is rough maths, you can sort of work out that you need that resistor to take 2.1 volts. If it takes up 2.1 volts, then you're not overloading your LEDs, and then they'll work. So basically, there's a bit of maths you can do to work out how big a resistor you need, and resistors come in ohms. Yep. But that's the hard way to do it. A far easier way to do it is to go to this website called ledlinear.org, and here it lets you on the left-hand side, you can put in your source voltage. All your LEDs have a certain voltage, so different ones have different voltages. If you press a question mark on the screen, it actually lets you select how much, what type of LED, and tells you what the voltage is, a diode, and then the number of LEDs in your array. As soon as you click on Design My Array, it actually draws down the bottom of the screen different solutions to show you how you can wire up your LEDs and which resistors you need to make sure that the power is okay. So this takes a lot of the hard work out. So if you worked out how many LEDs you need, and this will calculate how many resistors you need and the best way to set them up. Okay, so the last problem is how do we get 12 volts and 5 volts for a little circuit that you might want. So what you can use is a voltage regulator, and a voltage regulator is a small little chip, and it lets you use a couple of resistors, and you put the resistors in a particular ratio, and that formula shows you how that ratio works out. You can go to learningabout.electronics.com, and it's got a calculator there that lets you calculate it. But this formula here says with 2 resistors, I can get a 12-volt plug pack and wire up these resistors and also get 5 volts as well. So I can have 12 volts to run my LEDs and 5 volts to run my Arduino processor. One of the other elements is playing sound, and there's this great little chip called a DFPlayer Mini. It's around about $8 on the internet that you can find, and you can wire it up, and it's got a little a serial interface that you can hook up to Arduino, and you can send little commands to it to say, play this soundtrack. So you put a micro SD card into it and load it up with sounds, and it'll basically let you play a soundtrack when you want to, and you just wire it up to a speaker. So that was also another essential part of the enterprise is sounds. Okay, and it's got a fairly simple software interface that you're able to program to. So you set the volume, some of the equalizer output, and then you can basically send a play command to it and tell it which soundtrack to play. The picture I've got there is a breadboard that I had with 2 DFPlayers that I bought off the internet. Well, the first one didn't work, and the second one I unfortunately blew up because the little power supply that I had was 12 volts and not 5 volts. So be careful when you're wiring these up. Okay, so I've got a website that's got up on GitHub, a repository. You can go get all this sort of stuff, but here is a schematic that shows the full circuit diagram. So it looks a bit foreboding at first, but it's pretty easy. So color coding it is there's a little bit with the voltage, and that's the circuit that does gives you 12 volts and 5 volts. There's the yellow area, which is the audio, which is the DFPlayer. We've got the green area, which is all those LED circuits, which are, like I showed you in that website, you can go design those areas. There's LED switches, which are all the red areas. So they're all the little transistors that turn on and off the lights. There's the Arduino, and we've got some buttons as well, which you can press to change modes. I'll go through about how you set that up later on. So it's probably demo time, so I'll show you a little bit of what all this looks like. Okay, finally, this is the sort of electronics and how it fits together. Down the bottom there is some switches. They're on a little board. The next thing is the third DFPlayer that I had to buy to replace the other ones that I blew up. So that's the little audio player. If you look right down at the bottom of it, it's got a little micro SD card. There's a next board there is where the Arduino is, and there's along the top and the bottom of that board are all the transistors, and they just really turn on the power on and off. That's all they do. And there's a speaker, and there's a lot of cabling that goes up into the model itself, and there's the back side of the prototyping board, how it's been wired up. All those prototyping boards, they all start off very clean and they end up a bit messy by the end. So that's you should expect something to look like that. Okay, then there's constructing the model. Here's a term I did not know about, light blocking. I think I'd heard it before, but I didn't really know what it means. And when you're putting a model together with lots of lights, the models are usually made out of plastic, and a lot of light seeps through them. So to actually stop the light seeping through it, you need to have spray painted or light blocked internally. So you can use a black or a silver color or a really dark gray color, but you really need to coat the inside of your model so that the lights don't come out apart from the places that you want them to. So light blocking is very important. You've got wiring to do. In this particular model, because there was something like about 11 different circuits, that means you need lots of different colored wires so you know what you're hooking up to what. So that's very important to get some good colored wires. And after you've light blocked it, done the wiring, then you can go around gluing it. Okay, you can see in that picture there, this is one of the engines. There's a little resistor there, wired up to one of the LEDs, and I've just got them soldered up and hooked up the cables, and a different color for each different purpose in the model. So you really need it after you keep building it, because all those wires look exactly the same. Here's a bit more construction, putting together the warp engines. So there's lots of lights. There's four different circuits at least that go into the warp. So there's lights that flash at the back for strobes. There's lights for navigation. There's some spotlights, and there's also the warp engines, the blue things that glow. So all those have to be wired up. Here we are, getting a bit closer to the final assembly. So putting the model together, you have to do all the wiring beforehand. Everything has to be soldered up, and all the lights fitted before you can really put it finally together. And there it is, spray painted in all in white. And here are the pool room shots. So this is the Enterprise once it's been finished up a little bit more. So you can see there, it's got some like little light and dark grey spots on it. There are a lot of transfers that you actually have to put onto it. So it takes a lot of time to transfer all those transfers onto the model. You have to wrap it on the top and the bottom and all the sides. Yeah. So anyway, it came up pretty well, but ultimately it looks a lot better when the lights go out. And here's just a quick movie. Now, I should say at this point, it's actually playing on the audio track the Star Trek sound. So part of the program is that I set up that there's an audio track that it plays for different sequences. Yeah. Unfortunately, you won't be able to hear the sound on here, but trust me, if you've seen Star Trek, you'll know what it is. There's little areas in there I did not know, but there's apparently a park that's on the Enterprise full of trees. We have lots of spotlights. There's a crystal here. There's another room at the back. A little bit hard to see in these conditions, but it's there. There's lots of strobe lights flashing. There's navigation lights which flash at a different sequence. We've got spotlights as well that light up the model. I think there's about 14 spotlights across the ship. There's the interior. You can see a couple of shuttles in the bay. The underside, lots of more spotlights and strobes going off. And we've got a dish as well at the front. And the dish actually changes color to different modes. So when it's in impulse mode, that's a bit hard to pick up but it's a yellow color. And then when you press the warp engine button, it goes into warp mode. So here the warp engines sit there and pulsate, and the dish pulses along as well. And it plays the warp sound in the Star Trek sound. It's a little bit hard to hear at the moment because it's playing through my audio, but you probably can't hear it. And so after it's gone out of warp mode, and it goes back into impulse mode, which is when the dish is yellow, apparently. You find all sorts of things. Here are the photon torpedoes firing. So there's a photon torpedo button you can press. And those animate to kind of give the photon torpedoes coming out. Okay, so hopefully you got a bit of an idea of how many lights there are, what it looks like when it's all lit up. Okay. So now I'll just give you a little bit of a run through the software. I don't know if you've worked with an Arduino before, but it's fairly minimalist compared to an iOS environment. So here's the Arduino application stack. You've got device drivers and libraries at the bottom, and the rest of it is your application. There's two methods that you need to know about, setup and loop. Setup really initializes your application, and loop gets called all the time, and that's pretty much all there is to the application lifecycle in Arduino. The code is written as a C or a C++ type of code. Arduino is very rich. It's got thousands of libraries and plugins. You can find libraries for driving stepper motors, sensors, 7-segment displays, serial comms ports. It's really rich, but the language is quite simple. And so the Arduino application loop, so the sort of architecture for this particular model is fairly simple. You check your buttons, you check your timers, so you collect all your inputs, you handle some state changes, and then you'll run some updates of pin animations. I call them pin animations because you change the color of certain pins, or you change the output that go to certain pins. And then you go back and do it all again. So there is actually a state model inside that. So the software is set up so that we've got an intro. So it goes from an intro, and that runs for a certain amount of time. It plays the Star Trek music and brings on all the different lights. Hopefully in a future version that would be, the intro would turn on the sort of lights slowly to fit the music, but at the moment it brings them all on at once, and it goes into an idle mode. If you press one of the buttons called the warp button, it'll go into a warp mode, and what it'll do is start running a warp animation, and it starts playing the music, the wow 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 music in the Star Trek soundtrack. And once it's finished, it'll go back into the idle mode. There's also a power save mode. If you're running lots of lights inside a plastic model, those lights will heat up and the model will give way at some point. So it's actually got a power save mode. So if you aren't playing with it for a while, it'll actually start shutting down those LEDs and go into a low power mode. And then if you press one of the buttons, it goes back into idling, brings on the lights, and lets you do it. An extra area is setting some preferences, so you can change the volume of the music and the sound effects, but I haven't implemented that set. I've got the preferences state machine working, but I haven't set up all the preferences yet. So the Arduino key functions, there are a few more functions, but these are probably the ones that you probably need to learn about. It has a electrically erasable EEPROM, which is kind of like an SSD. You can store preferences and those sorts of things. So it's a fairly small chip. It has a little bit of RAM, has a little bit of ROM, and it has ROM that you can store your own things like preferences in. So that's one thing, the EEPROM, being able to read and write to that. There's pin functions. So we've got pin modes. So you can turn a pin as an input or an output. You can do a digital read, which reads a pin and says, is this pin on or is this off? So you use that for a press button. There's an analog write, which lets you write a value to a pin. And it's analog, so it lets you give a value between like 0 and 255, which will change the, if it's a pulse width modulation pin, that will let you change the amount of energy that goes to the pin. And a digital write pin, which is basically turns a pin on and off. So those that you can really use to drive your lights. And finally, on time, there's a millis function, which gives you a timestamp in milliseconds. So use that for timing. So you can work out, if the time has expired, then you can work out to start an animation or stop an animation. And it's used in animation functions, which I'll talk about in a bit. So there's a couple of utility functions. One I've got in the code base is for doing buttons. Buttons in the microcontrollers are a little bit tricky because usually when you press down on a button, we think of it as just on or off. But what actually happens in the electricity is that it's a really spiky little signal. So it doesn't really just go on or off. It goes up and down, up and down, up and down. So there's a trick called button debouncing that you need to implement, which these little functions will set up a button and call a button check function, and that will actually make sure that it skips all of it. It runs a bit of a timer and that sort of thing. You can look up debouncing if you're not familiar with it. I've got a very simple animation library called pin animation functions. So these are, you can set up a pin animation data structure and start and stop and animate pins. And it runs multiple of those pin animations at the same time. So you can sort of be having your lights flashing on some circuits, other lights flashing at a different sequence, and also be changing your dish, changing it from yellow to blue and blue to yellow. Okay, so the pin animation, it uses a data structure, which is basically configured to your preferences. So an animation can animate multiple pins. So in the case of some of those, the dish that has a red, green, blue RGB LED behind it, it lets you set a pin for each one of the red, green, and blue components. So you can animate each of those values separately. It has an auto repeat, so things like those navigation lights that keep on flashing, you set the auto repeat. Is analog if it's just lets you change it for RGB. For some lights, they're just a simple on and off, so that sets that flag. And we've got a smooth animation, which means it's meant to interpolate the values rather than just simply jump from on, off, or values. So in that little library, it's got a bit of interpolation, so it'll go from one value to another value over a period of time. And here's an example of the dish animation. So this little set of structures is the pin values for going from a dish going from blue to yellow. The first set is RGB, so it's 0, 0 to 55, so that's blue. And then the next value is 255, 255, 0, which is yellow. And then we set a duration of 2 seconds. So from the first color, which is blue, to the second color, which is yellow, it'll run that animation for 2 seconds. And the little graph over there really shows how it's animating those colors and changing what the pins are doing and changing what the LEDs look like. Okay, so there's a couple of resources if you want to get in touch with me. There's ignitedsoftware.com or Ignited Software on the Twitter. All the source code and the circuit diagrams are up there on GitHub at Mike Bonner LCARS. And we've also got TrekWorks on YouTube, which is a fantastic series, which I learned so much about building one of these models and doing the lighting as well. So there's a whole series of some guys build that particular model. They used a different Arduino and controller circuit, but anyway, you can use the one I've given you and the code. And it's got some great tips of how to construct that model, set up all the different lighting, and actually make it work. There's some things that just aren't in the user guides that come with the plastic model. And that's it from me, really. So I hope you found that useful, and happy modeling, and hope you found something useful out of it. Okay, thank you.
Okay, thank you, Mike, for the amazing talk. I hope someone of us will try to make that model. But still, it's, I think, a lot of work, and I hope someone learned from it. So a quick shout out to Mike. So if you guys have any questions that you want to ask Mike, you can jump on our Slack channel, on the Meetup channel, and you can talk to Mike over there. Okay, let's move on to the next talk. It's basically me presenting. So it's my experience creating a learning game. So let's begin. Okay, so for context, let's start. My name is Ojas Chimne. I'm from India. So I came to Melbourne 2 years ago to do my master's degree in IT from Monash. So currently I am just a week away from completing my degree. And apart from that, I am a part-time tutor at Monash. I teach an Android unit at the Clayton campus for the bachelor's. And my previous work history is I've worked as an Android developer, and then I switched to an iOS role. And then, so let's start with the talk. So the name of the talk is my experience creating a learning game. So before I talk about that, I'll give you a little background. So during my master's degree, so this is currently my final semester, and Monash has this industry experience program, which runs for 3 months, and it's basically like a very big hackathon. And at the start of the semester, they give us a topic, and based on that topic, we have to make use of technology for the social good, and we have to come up with a solution. So at the start of the semester, we got a topic called reducing injuries and deaths related to water. So we were divided into teams of 4. So first thing that popped into our mind when we heard this topic was, let's do something related to shark attacks. But the good thing is that Victoria does not have any fatalities for the last 30 years. So there have been injuries based on shark attacks, but there have been no fatalities. And we researched a little bit more, and we found out that the state of Victoria has a lot of resources and applications that already encourage people to stay away from shark-infested waters. So instead of trying to solve a problem that has good solutions out there, we went and researched a little bit more, and then we found a report which suggested that Victoria has around 56 drowning deaths that were recorded in the year 2018 and 19. So this is what we stuck upon, and we thought, let's try to see what there is something over there. And we dug a little deeper, and we found out that on average, 5 children aged from birth to 4 years drown every year in Victoria. So there are a lot of cases where children drown or are injured around beaches or swimming pools. So we looked up if there were any applications or any websites that help children learn about water safety in any way. So we found a few, but there were not that many. So we came up with the solution to make an iOS mobile game for children. So the idea was that we were initially going to make a questionnaire type application that the children will go through, but we later on found out from our tutors and doing a little bit of research that children generally don't have that much big of an attention span, and they generally will delete that application or close it if they are not interested in it. So we thought, instead of just making an educational application, let's convert that into a game style format. So the initial plan was to create a quiz type game. So we had 2 iterations. So in the first iteration, we came up with a very simple quiz game where there were questions being given to the children, and based on what answer they chose, they would be shown if it was a right answer or a wrong answer, and what were the implications of choosing a particular answer. But because the game was not visually attractive, so we added a lot of other elements into the application. So we added these beautiful images, and we also added background music, so that really popped the application. So as you can see in the screenshot over here, so once you start the game, you get two scenarios. So there is a beach scenario and a swimming pool scenario. So these scenarios are basically that we wanted to cover for the second iteration. So inside the beach scenario, there were two storylines. So all the questions inside the game, they have been planned in a story type format. So it's not just like question one, you give an answer and it goes to question two. So it basically has some sort of a storyline, and all of these questions have some sort of safety instructions on questions inside of them. And if you look at the second screenshot, it shows the different storylines. So we added a few fictional characters to the game. There was a unicorn, there was a fairy, and there was a turtle. And then once you start a particular story, then so that is how it looks. That's the third screenshot. So there's an image on the top, there's a question, and there are two options. So based on the answers that you choose, it will prompt you that, yay, it was a correct answer, and it will give you a small description on the bottom why it was a correct answer. So if you choose an incorrect answer, then it will play an audio or something like that. So I'll show you a demo later on, and then you will get a clear idea. Okay, so let's move on to the demo. Let's go back. Okay. Let's run. Okay. Okay, just starting up. Okay, so this is the home screen of the Helping Harper game. So we have two buttons over here. One is the play section, and another one is a revision section. So let's start with the revision section quickly. So the revision section is basically like an educational side of the game. So this is where the children can go and learn about different safety symbols, and we have categorized them based on their colors. So we have beach flags. So there's a warning flag, evacuation, beach patrol, and we have beach patrol feather. Let's go back. There are red symbols. So beach closed, no swimming. Pool closed, no fishing, no swimming. So these are the prohibited symbols. Then we have the yellow symbols, which are the warning symbols. So deep hole, deep water, shallow water, shark. So this area is basically for the children to learn about the different symbols. And once the children learn from that section, they can go into the play section. So we have two scenarios over here. So one is beach and the other one is swimming pool. So let's open beach. So I'll open up one of them. So every story has around 10 questions. So I won't go through all of them. So it takes around 10 minutes, I think, to go through all of them. So I will just show you guys the first 2 or 3 questions, and let's start the story. So it also has an audio. I think it's playing right now. Okay, so you won't be able to hear the audio, but all of these texts on the bottom have been recorded by one of our team members, and then we are playing it according when the screen comes up. Hit continue, and then we are asking the person or the child, whoever is playing, can you identify the sign and what should Harper do? So Harper is the fictional character in the game. So we have two answers on the bottom. So the first one is tell mom about the sign, or the second one is ignore the sign and explore. So if you say let's ignore the sign and explore, yeah, so that's an incorrect answer, and you can read about why that is the incorrect answer, and then the game will move on. So Harper is wondering in which area of the beach, you should go for a swim. Let's continue. Yeah, so we know that you have to swim between the two flags. So let's click on between the two flags as the answer. Yay! So that's the correct answer, because it's safer to swim between the flags as the area is looked after by lifeguards. Okay, let's continue. Do you know what that is? What should Harper do? So you can either swim faster to get the ice cream, or you can tell Mike to come back. So let's go with swim faster to win the ice cream. Okay, that's the wrong answer. And let's hit continue. And yep, so this is basically how we structured the game. So we have like different storylines. And I can show you guys one more story. So this is for the swimming pool. So there was the story is magical pool. So there is this magical fairy Pico who comes at night and takes Harper to this beautiful swimming pool. And then there are 10 challenges, and then Harper is at a swimming pool, and then she's asked her, do you know what they are? So are they graffiti or are they depth markers? So if we go with they are depth markers, yeah, so that's the correct answer. Okay. So I'm going to upload this to test flight soon. So if you guys are interested in testing this app later on, and you can hit me on Twitter. So let's go back here. Okay. So what did I learn from this game? So I don't have any experience in game development. So I've only worked on traditional applications. I've worked on a gym management application and a e-commerce application. So this game development was pretty new for me. So what I learned was that you have to approach game development in a very different way. So there is a lot of research and experimentation that you have to do. So there is no fixed formula to say that this game looks better when you do a particular thing. So it's best to just trust your intuition. So if you like a particular thing, so the best thing to do is if you build a particular feature, you get it tested by your target audience. So in our scenario, our target audience was children between the age 8 to 12. So we got the application tested by a 10-year-old, and she gave us a lot of feedback that we should fix this thing, we should add this particular font. She liked this particular font, or she liked these animations. So that's what I learned. So game development is quite different than traditional application development. Yeah. So I hope you guys enjoyed listening to this short talk. Let's move back to our yep. Okay, so we are at the end of today's meetup. So I would like to thank everyone for coming, and I would like to thank all of our sponsors for helping us out. So you can look into our next month's meetup on meetup.com, or you can join our Slack at slack.melbournecocoaheads.com, or you can reach out to us on Twitter, and you can also look at the previous videos on YouTube. Okay, so the next event will be on somewhere around July, and probably the second week. So yeah, I hope you guys enjoyed, and yep, bye.